Yeah, it's sharing now.
What do I say?
Or I was saying, or are we doing question 3 today now?
Where did we end?
Mm, let me just verify again. We ended where we were doing those ones, the derivative ones. Mm, where you said you're gonna send the notes on how you did.
Or what
It
I
was
was supposed to
question.
send? It's only the ones for the integrals, isn't it?
It was question 3. We did
Yes,
question
which
3.
is
Yeah.
how we maneuvered from here,
Mm,
which I said I was going to send the form.
yes.
All right. So
So
let's
now
do,
we are doing
yeah, number
um
3. Number 4.
number 4. Yes, because we
Right.
already did number 3.
All right. I will send that
Okay.
attached to that one. I will just screenshot, then I will put the
Or
formula
even
that.
the recording. I think you forgot to forward the recording as well for that day. When was it? It was last week, ne? Thursday.
No problem. I'll send it.
Okay.
So we are doing number 4.
Okay. Also after this lesson, I want to ask you about next month the preparation,
All
but we
right.
can after the class. Yeah.
You wanted to all right.
Yeah, we can discuss it after the class. It's
Okay.
fine. Yeah.
Using is the screen still sharing?
No, not yet. No, it's no longer sharing now. Something shifted.
But using before. Yeah.
Yeah, it's sharing now.
Okay.
Yeah.
So, uh, number 4. So for number 4, prove the following commutation relation, which is LZ. LZ. LZ is commuting with cos squared phi. It's equals to 2i h bar. So it's 2i h bar multiplied by sine phi multiplied by sine phi cos phi. Where phi, having a charger problem here. Apologies for that. All right. Where phi is the azimuthal angle, that phi, and we use AB if we are commuting A commuting with BC. First you take out the B, then you commute with the AC, the order it matters, which means you are adding. So whenever you see the rule says that comma which is in between, that is what we say it commutes. So if A, it's vector A commutes with BC, what do? The order it matters. Remember, B is sitting on the left of what? Of C. So always, when you take the B outside, it must be on the left of C. That's why the B is outside here on the left, sitting on the left. A commuting with C. And when you take C, it must be sitting on the right-hand side of what? Of B. I'm repeating again. Let's do it using an example. Because those commutation relations must master them. Otherwise, if you don't, whatever that we are going to discuss, it just near me. A, if they say A is commuting with BC, what it means in terms of vectors. All right. Just scrolling there so that I check where you do the vectors. All right, let's just see. It's fine. You just need to recall your knowledge of vectors. Whenever you see the commutation relation of A, and remember it's a square bracket, A is commuting with BC. If A is commuting with BC, you indicate this is equals to. Then A remain where it is, comma. So if I decide to take, hello,
What is to commit?
is the commutation relation. For example, if I want to say when something is commuting, for example, you write the order of, for example, if I say P is commuting with the X, if P commutes with X like this, in other words, I am saying P multiplied by X minus X multiplied by P. So this expression can be written as a commutation relation of P commuting with X. In other words, whenever you see an expression like Px minus Xp, if you don't want to write it like this, you can use those square brackets. That is what we mean by commutation relation. I don't know if you answer.
Yeah, I didn't know, but
Eh?
I didn't know about this, but I understand.
Yes, that is the commutation. So whenever you see this one, commutation relation, in other words, whenever you are given an expression where it says AB minus BA, so this expression can be written as A commuting with B. So that is the definition. So you'll be saying A, B minus BA minus the reverse. You start with the forward, A times B, minus the reverse, B times A. But in this case, the order, it matters. The order, it matters. The order, it matters. That's why here, when we were doing the commutation relation of A commuting with BC. So if A is commuting with BC, like what I was indicating there, A, that comma there indicates commuting with BC. It commutes with BC, like so. This it indicates that. So first, the order, it matters. A commuting with B. All right. But as you can see there, B and C, they are multiplying each other. And where relative to B, is C to the left or C is to the right? Relative to B.
It's on the right.
Is C to the left of B or C to the right of B?
It's on the right of B.
It's on the right of B. So
Yeah,
that's why on the commutation relation here, C is on the right of B. So if you are writing it like this, so which means if you are putting the commutation relation, you are going to put the C on the right of B. But because these two, it's a chain rule, they are multiplying each other, then that's why you're also adding plus. Then you say A. Now, since you have chosen, what is it, B on the product which of the two which we're multiplying each other, now we are choosing one of them, which is the remaining one, which is C. Right. Then you are checking now. B, is B on the right of C or B is to the left of C?
it's on the left of C.
It's on the left. That's why we are writing B in front here. That is the commutation relation. So the order, just setting up that equation of the order of the commutation, these are marks. Those are the marks. So must know what it means whenever they talk of commutation relation. Right. So that is the hint that we're given. So whenever you're doing the commutation relation, you do it like that. Then what does L indicate? L is what? L is angular momentum, isn't it? L, whenever I see L, is the angular momentum.
Yeah.
Right. L is the angular momentum. L is the angular momentum. And the angular momentum is minus I h bar partial. So as a vector, minus h bar h, since you are dealing with the z, which means it will be partial phi of that function, r theta phi. So L is negative I h bar partial phi. So these are the tools that you were given already on the question. You did not derive. You were given the hint that when you want the angular momentum in the z direction, the angular momentum in the z direction, it's minus h bar partial, then you differentiate that function. So those are the tools that you are going to use. So what are we trying to achieve? This question, we check. Prove the following commutation relation. So you want to prove that commutation relation, this one. That LZ commuting with cos squared phi, it will give me that. Right. So let's prove that. That is number 4, question 4. All right. So L commuting, this is what we are supposed to prove, right? So what are we given? We are given this information that L commuting, L angular momentum in the Z direction minus h bar partial phi. All right. And that is what we are given. Then let the commutator act on any function. Is the screen sharing? On any function f of
Yeah, the
phi.
screen is sharing.
So the function is the function in terms of phi. Our function in terms of phi. All right. So phi, it will be a function. It's not a function in terms of x, but the variable there is phi. The variable there is phi. So which means LZ commuting with cos squared, then that function which is outside here, which we have put the phi, is the function, which means it's the function in terms of phi. That's what that is the f. So now, if that f is sitting there on the right, what does it mean? You can use the commutation relation, which says since it's sitting on the what? That f is sitting on the right, not on the
On
left,
the right.
sitting on the right.
Oh, so
So
basically here, the LZ is the A, and then the cos squared is the B, and then the F is the C.
yes,
Oh, and then
A, B, and C.
the cos
So
squared
want
is
to
on
find
the.
that commutation relation of those. So which means
Oh,
LZ, it goes. So it's not, in other words, I am saying LZ. So it's the first multiplied by the second. But because always, if I am dealing with the second one, whenever I deal with this one, which means this times this, always the F must be sitting on the right. That is the yin. Can you see that the F is always sitting on the
on the right. Yeah, the C, which is
always?
the C in the
After
example.
you have multiplied, the F must be there on the right of that expression. In other words, the last, in other words, it must be always on the right or the last term, which is F,
Oh,
since you
the
are seeing it.
orders matters.
Yes.
Oh,
So which means the commutation relation, we are saying LZ multiplied by that, multiplied, so which means these two terms, you multiply them together. That is, you get this first term. But not forgetting that this F must be always sitting on the, because here on the expression, it's on the right. Minus commutation relation, which means I told you the relation says minus. Minus, now we are starting with the right, which means the term on the right is cos squared phi. So it's cos squared phi multiplied by ZLZ. After you multiply by the LZ, don't forget to put the what? The F as the last term. Why? Because it's coming from this idea that F is sitting there as the last term. That's why you're seeing that all these functions, they are ending with what? With F. Any question?
so the commutation, is it always like this, or it depends on the hint that they give you, or is it something
No,
that
no, the
changes?
commutation, the rule does not change. Because
Oh,
here we are just saying, if it's a commutation, like here I've told you the commutation of A and B. And
mm,
then there's a commutation relation, which is described there in the question. We are having a commutation relation of A and B, but C must always sit on the what?
on the
On
right
the right.
side.
So this is the same as first it's A multiplied by B, but the C is sitting on the right.
Oh,
Then minus this times that, which means B
times times
times A, which is BA.
A, and the C on the right.
And C
Oh,
is always sitting on the what? On the
on
right.
the right side. Oh,
So this is what is it? Because that is the order. But when you are doing the reverse, you must not forget that you are subtracting. All right. So that is the only trick that you must master. That you don't forget that you are subtracting. Okay. Sitting on the right. All right. So from here, now you substitute. your variables. You were told that use LZ to be I H bar partial phi. So use that LZ to be I H bar partial phi. So which means I am going to replace where there was LZ. What do you put? Where there's LZ, you put this is your LZ. This is your LZ. So where there is cos squared phi, partial, so your LZ, it is partial IH bar, and then there is the F, which was always sitting on the right. Now the expression becomes like, so this is LZF, LZ of F, because F was always sitting there on the right. Any question?
So you don't leave the F to be the that equation of LZ, and then you put F on after that equation. Why can't you keep
Remember, if
them?
it's partial phi, if it's LZ multiplied by F, like on this equation, it's LZ multiplied by F on this equation, LZ multiplied by F, LZ multiplied by F. So that is how this expression has changed from here to there, because it was LZF this last term. I don't know if you understand.
Like on
We are
the last
saying
one,
last term, this last term, this one. Can you see that it's LZF? LZF, this one.
Oh yes, okay, yeah. Now,
So that LZF, now we are told that LZ is minus H bar partial phi. But because in front of LZ there is an F, that's why it is going to be partial phi of F. Now we get.
oh,
I don't know why my phone charger is not charging. We're having a problem. I guess the phone wants to go. Right.
yeah, I can see it's popping up.
All right. So that's where we are now. The phone is freezing. Right. All right. So from here, after we substitute the LZ, it's minus H bar. Then partial phi of F, it was replaced by LZF. Then you put minus H bar partial. So now you just differentiate using product. How do you differentiate? Let's start with the first one. LZ cos squared phi F. So which means we are having minus I H bar, which is a constant. I is a constant, H bar is also a constant. Then what we are going to differentiate is what is inside the bracket. But inside the bracket, you have two functions, cos squared phi, and you have function f, which is also in terms of phi, f of phi. Why is f in terms of phi? Because we already stated it that here. When you are proving, we said this f that we are dealing with, it's a function which is also in terms of what? Of phi. It's not f of x, but it's a function which is having a variable. In other words, the expression is written in terms of phi, not x or y. So that's why when you get an expression like this, LZ, when it comes to minus H bar partial, so when you are differentiating this, what is inside the, you are differentiating this with respect to phi. That is what you are doing. That's why it is product rule, because those two functions, cos squared phi and f, their product, they are multiplying each other. So you differentiate them the same way you use product rule. Okay. So you differentiate the first one, keeping differentiate the first, keeping the second one as constant. And then you keep the second as constant, and then you differentiate the second product rule. Is it clear?
Yes, sir. Yes.
What are we doing? We are not interested with IH bar first. Negative IH bar there is just a constant. So first we are going to differentiate cos squared phi f using product rule. So what do? You differentiate the first term according to product rule. So you differentiate this one. You keep f as a constant. Then you add calculus. Then you keep the first one constant. Treat it as a constant. Then you differentiate the second term. Product rule. You know your maths very well, then you can understand that.
Yeah.
Then now we are going to differentiate. But the partial of cos squared phi over 2 over partial phi, the partial of cos squared phi over partial phi is equals to that. And let's check the question. All right. So can you see that here? That information was not given. Where did they get this one from? This information, where did we get it from? Which is 2IH bar. Where are we getting it? How did we arrive here? After the product rule, yeah.
Isn't it differentiation?
If you
When you
differentiate cos squared, what do you get?
get I said two sine squared cos squared.
Yeah, that's what I'm asking you. So which means this is cos. Now if you like this, it's cos phi.
Mm.
And then this cos phi, you are differentiating with respect to what? Phi.
Mm.
Then this cos squared is being squared as well. So I'm saying when you differentiate, when you're doing calculus, how do you differentiate this one? What do you say? If you differentiate cos, what do you get?
Negative sign.
Negative sign, isn't it? But
Yes.
before you differentiate cos, chain rule. Remember chain rule, where we are differentiating, and this module is just mathematics, pure maths here, my in
It's
quantum.
pure maths. Oh, I have to
So you
practice
very
my
well,
differentiation.
quantum, we are not going to be friends because product rule, chain rule, they always apply. So we are saying we want to differentiate d phi with respect to, differentiate cos
Cos phi squared.
phi, then you square. So any expression squared, if you are differentiating, you start with the 2. This 2, remember the xn rule. So the 2 becomes the coefficient here, 2 multiplied by. Then you say what is inside the bracket, it's going to be cos phi. Close your bracket to the power 2 minus 1. Then multiplied by the derivative of what is inside the bracket. What is the derivative of cos?
Minus sign.
So which means multiplied by minus sine phi, not x, minus sine phi. So which means a negative And the cos to the power 2 minus 1 just give you cos to the power 1. So the answer becomes negative 2 cos pi
Sine thigh.
sine pi. So this Greek symbol is phi. Any question?
No question.
So that's how that derivative was obtained. It's a pure math. And here it was not calculated the way we did. It's just saying, so in an exam, we must know how to differentiate. So we move from there. Now we have our derivative. And which part were we working on? We were just working on this
The first one,
first
the
one,
cos
where we
squared
are
thigh
saying cos
f.
squared. Yes, and then f, and we have not touched the other side. So you can see it's pure maths where you are joining everything, right? So f, so now we have differentiated everything. Then what is left? You must multiply by what? By f. Can you see? Multiplied by f. Then the other one on the right, you keep cos constant, cos squared phi constant, and then this one, you multiply by what? You multiply by f on the right.
Oh
Then the
yes.
negative IH bar, this one, it was already there, but we said it's a constant. It's already there in front. But the fact that the negative IH bar is also appearing even on this side, if you can see that negative IH bar is common. Can you see negative IH?
Mm-hmm.
And here there's negative IH bar. So which
Yeah.
means we can take out the negative what?
H bar.
IH bar.
IH bar,
But
yes.
before we take out the negative IH bar, check something. Negative times negative, what do you get?
It's a positive.
So it's a positive IH bar, which we are having,
Oh.
positive IH bar. So what happens if I factor out a negative outside the bracket?
Everything that was negative becomes positive.
All right. So check here, it's also a negative. Here, it's also a negative, which we got here. Negative 2, multiply by that. So negative 2 times negative 2, we are going to see that this negative and the negative, they give you also a what? A positive. That negative and the negative, they give you also a positive. But we only took out the negative IH bar. That's why on the right-hand side, check on the right-hand side, what you are getting on the right-hand side. Where there is a negative, cos. That's why the negative times negative, what do you get? Negative times negative,
So
positive.
sorry, the negative two, was it not supposed to be positive two since well you took the negative outside
For which one?
for the downwards the last one where
When
you
we are
took
dealing with this first
the
expression,
one
which one?
that you
This one.
took the negative h bar outside.
Remember, this is product rule, isn't it?
Yes.
Yes. So for the first part, when you do your product rule, it will look like this. Then the whole term, this is what we are going to multiply by a negative IH bar outside. So we are saying if you differentiate that first term, you are getting minus 2 sine phi cos phi. Then you are going to add it to cos squared phi, partial f of partial phi. So if you are going to replace, what has only changed here is that you are just multiplying this term. It did not change, and still the same as it is this one for the first bracket. And then the negative IH bar is sitting outside. That's what I'm just saying. The negative IH bar is sitting outside. Why? Because that negative IH bar is a constant. So whether you are going to multiply the brackets times twice, the constant should be outside. What you are interested to differentiate is what is only inside the bracket. Now we are going to the second part of the negative, where I was saying negative times negative, it gives you a what? A positive. So on the term which is coming next, there is no factoring out IH bar. We are just multiplying the negative times negative to give you a positive, which is this positive, which we are talking about. This one. That positive. It's negative times negative, give you a positive. Any question here?
So
You want to
nothing
ask?
else changes.
No, we did not change anything there yet.
Oh, okay. That's where I was confused.
We are just expanding. All right. Then from there you expand. Now we are multiplying each term one by one. When we're expanding, I'm applying each term one by one. Right. So now we are expanding. So if you expand, which means the IH bar, negative, negative becomes what? Positive on the first term. So it will be positive 2IH bar multiplied by sine phi cos phi multiplied by. Then that negative, 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 this one. Let me use a different color so that don't get confused. So this negative, yeah, times the positive, it gives you a negative. Any question? So we are
No.
saying this negative times this positive, it gives you a what? A negative.
Mm.
So that's how that negative was obtained. That's how that negative was obtained. All right.
Wow.
And then we move to the next term. We move to the next term, which is the positive I h bar squared d phi d plus I h bar cos squared phi df d phi. There we did not change anything. The term just remained the same. It was not expanded because it's already expanded in its form, simplest. So there we did not expand anything. All right. So as you can see, this is our term. So it's still the same with the upward. So the last term, nothing changed. These terms, they are still the same. These two, they are still the same. However, we only expanded the minus IH bar. Then from here, the last two terms are going to cancel. Do you agree?
Mm. I agree.
Are they the same? The last two terms, are they exactly the same?
Mm.
Minus IH bar cos squared phi df.
Yeah, they're going to cancel.
So these, they cancel out. And what are you going to be left out?
2 I H bar sin thigh cos thigh f.
And there is f. But on our question, is it having an f in front? Check the original question. Was it having an f in front? Check. Is it having an f? The original question. It's not.
No, the f again came after we used the chain rule.
Yes. So you must also conclude again so that it comes to the exact where you remove that f. The f you introduced it when you're trying to calculate it.
Mm.
So the two terms cancel. Which are the two terms which are going to cancel?
You divide by f both side.
by f both sides. So if the two terms cancel, what are you left with?
2h I h sine
2i
phi
h bar. It's 2i h
h
bar
bar sine
sine
phi
phi
cos.
cos phi.
Yeah.
That is the answer which we have proved. So are you able to do it on your own without looking at them? All right, just a recap of what we've done so that we just refresh your memory. So this is what you are supposed to do. So now that you know that LZ commuting, if something commutes, which means we are trying to say, we are saying LZ multiplied by cos phi minus cos phi multiplied by LZ. And remember, the order, it matters. So whenever you see an expression which can be written like this, in other words, they are saying LZ multiplied by cos squared phi, cos squared phi, minus cos squared phi is the reverse now, minus cos squared phi multiplied by LZ. Like that. So this expression can be written as a commutation, which is, so this is what you are trying to do. So a statement, when you ask what does commutation relation mean, this expression can be written like this in terms of
I think the
commutation
trick was on the commutation, that
relation.
is
Yes,
relation, and also the derivation as well.
yes. Right. So which means that is the commutation relation. So
Mm.
that is what you are supposed to do. And you were given one of the parameters there, which you can use, which is LZ is just I, negative I, H bar, partial phi. But when you use partial phi, you must be having that function, which is in terms of phi. That's why we had to let that function be a function of phi, because you can't use partial phi, yet there is no that function which is in terms of phi. So that's why we add a phi, an f in front of that commutation relation.
Yeah.
Because when we are going to differentiate, we want to differentiate that function, which is f. So you can't be just having partial phi of what? Then you must indicate partial phi of f. That's why the f was introduced there. Then the f is sitting on the right. So whenever you do your commutation relation, always make sure that the f always sits where? On the right.
On the right.
And it's sitting on the right. Of what? On the right. Cos squared phi. It's always on the right. So after you commute, you multiply by f that function. So that is the commutation relation that we used. Then next step, you are supposed to identify, before you identify the product, you substitute the LZ. Now you are introducing now the negative I H bar partial phi. You've introduced it. Where there is LZ, you replace. Where there is LZ, you are just replacing. At the same time, while you are replacing, at the same time, you are also giving the definition of the commutation. Can you see that you have replaced LZ, and also you have defined what does this commutation relation mean? It's LZ minus, this is the definition. So this is the definition of commutation relation. Then you substitute the LZ, the LZ that you have substituted. Then from substituting the LZ, you identify that no, partial phi of cos squared phi of f is a product rule. So product rule, you treat it as wise. Differentiate the first, keep the second one constant. Plus, keep the first one constant, differentiate the second one. That is the product rule. Not forgetting that I h bar was outside. Since these are constant, I square root of negative 1, h bar 2 Planck's constant over 2 pi. It's also a constant. So don't forget that there's negative I h bar outside. But when you differentiate with respect to phi, cos squared phi, it gives you negative 2 sine phi cos phi. Why? Because cos, when you differentiate, it gives you negative sign. And the 2 which is in front there, the exponent becomes the coefficient in front. That's where the negative 2 sine phi cos phi came from. Now you replace those values into the equation. Negative IH bar sitting outside, then you replace, copy it as it is. Then the last term was negative, 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 it became positive. That was the last term. That's why the last term is always a positive. Once you miss that sign, they are not going to cancel out. So your signs, they are very important. Negative, negative, positive. Then you just expand the bracket. After you expand the bracket, negative, negative, negative I, H bar minus 2, get a positive. Then that positive plus a negative. After you expand, you are going to get a negative cos squared phi partial f over partial phi plus that one. Then those two, you say they cancel out. But you still have f in front. Then the f should also disappear so that we are only left with the quantities that we need to prove. Then the solution is done. Question number 4, 10 marks.
And I think this thing are gonna come in the exam. The way they're taking
It's
time to say,
commutation relation, whether you like it or not. Commutation relation, they're always there in a quantum exam.
just like question
Commutation
one,
relation,
that
they're
one.
always there. There will be a question on commutation relation quantum exam. You can't write a quantum physics without commuting. No ways.
Even the Schrodinger, I think is gonna come back. The question one, that one.
It can be in a potential well, it can be, yes, that one in a potential well. Then they can change the dimensions of the things. So you must master the technique that one.
Yeesh.
Right.
Oh, I need to put an
Then
effort in this model. Yeesh. I
this one is more of maths. It's more of maths.
Yeah, I think I'll start by practicing my derivation and everything, my trigonometry first. Then
Yes, maths, maths part.
yeah, before I can start.
Because
Uh,
last time we're differentiating, remember the exponent.
mm,
Chain rule, when you differentiate an exponent, it brings back the exponent, then multiplied by the derivative of what was in the exponential equation, e. So e, when you differentiate e, it brings back the e. That's like what we're dealing with, e to the power minus omega I kx. You still remember? The derivative was like this, where you are supposed to differentiate e to the power I
mm,
kx
KX.
minus omega t.
T,
So
yeah.
you differentiate, the question says partial t of this. So which means you are differentiating with respect to time. Then it can go and say partial x. Remember, now you don't want to differentiate with respect to t. Now you want to differentiate with respect to x. Then it will be partial x. Partial x of what? Of the same I in bracket kx minus omega t. So you must be in a position to differentiate with respect to t, whereby you bring back the same function, then you differentiate this top part with respect to x. And not forgetting the I, it's also multiplying. K is a constant. Omega is a constant. The only variables are x and t. Ik, omega, they are just constants. All right, so we'll stop here for today. I will share the recording for last week and today's so that we can catch up. Then we'll finalize the remaining questions on Thursday.
Can you also please forward me these notes? If you have them somewhere, then the notes for these things,
All
the
right.
one that we are doing in class, not the ones that you send me for the correct. Like, I think they'll be also be more helpful.
No problem.
Okay, it's fine. Maybe because we have other classes, maybe we can
Yeah.
discuss on Thursday before class. Because I want us to talk about how we're gonna break it down. The exam preparation.
Yeah, no problem. I will contact you when I'm done or even tomorrow. It's fine.
Oh yeah, even tomorrow, yeah, we can just maybe we can chat. It's fine. When you're free, just
Yeah,
send me a message. Okay. Thank
that's
you. Bye.